Hello, how are you? All right, so let's read the problem. So, what volume of nitrogen in liters can be produced by the decomposition of 93.1 grams of NH4NO2 that decomposes to nitrogen gas and water? All right, so we have so basically this is a two-step problem. It's a ideal gas problem and a stoichiometry problem from General Chemistry 1. That's typically where you see this type of problem. So basically, the way we're going to start this is um, we're going to balance the chemical equation. You can see I got a purple one, a red one, and an orange two. So those are the molar coefficients that balance this chemical equation. Of course, I got the 93.1 grams of NH4NO2, and they want to know specifically. I actually don't mind this. Specifically, they want to know what liters of nitrogen gas that can produce. So let's go to the first step. All right, so this is the ideal gas part. This part is fairly easy. It's just straight up algebra. So PV is equal to nRT. That's the ideal gas equation. P means pressure, V means volume, N means moles, R means the ideal gas law. There's more than one ideal. The ideal gas. The ideal gas coefficient. So there's more than one ideal gas coefficient. They're really differentiated by the units. So as you can see, I got the units right here. That's the most important part. Pay attention to those units because they cancel out and give us our answer. Liters times atmospheres divided by, what is that? K is, what is that? That is not, that's Kelvin. Kelvin and moles. So basically, to solve for the volume of the nitrogen gas, we have to solve for V. So basically, the way we're going to go about this, so you have to understand this conceptually. Like I said, you have to understand that we're going to start with stoichiometry, then go to the ideal gas law. So basically, you can see that. Let's just solve it. So R, we know what R is. I got R down there. The pressure. They gave us the pressure. They said the pressure was 120 atm. Atm is atmospheric pressure. So we got the pressure. Volume. That's what we're looking for. The volume of this is in liters, just like the ideal gas constant. We're looking for the moles. We're going to find the moles through stoichiometry, and they gave us the temperature in Celsius. It's 25 degrees Celsius. To convert Celsius to Kelvin, you just add 273.15. Okay, so this is the hard part. So basically, we take the 93.1 grams of NH4NO2, multiply that times the moles of that. So basically, what I'm doing here is setting up something called dimensional analysis because I'm trying to get these units to cancel out so that I can end with moles of nitrogen gas. And the reason I can do that is because I know the molar coefficients. I know the molar coefficients from originally balancing the equation. For instance, if I was to use the same colors right here, so basically these two ones, that one on top would be red and that one on the bottom would be purple. All right, so basically that's the key here. You got to understand the molar coefficients. So basically, these cancel out, and I can go from grams of NH4NO2 to moles of nitrogen gas, and I come up with 1.4533 moles of nitrogen gas. I can actually take that and plug it into this to find this volume of so to go from the moles of nitrogen gas to the volume of nitrogen gas. But again, to do this, you got to know a little algebra to go about doing that. You just divide the pressure on both sides. And when you do that, you get a brand new equation. It looks like this. Volume is equal to moles times the ideal gas. Well, I'm just going to use the letters, makes this faster. V is equal to nRT divided by P. Solve for V. And basically, you take the moles we found earlier. You take the ideal blah, blah, blah. You take Kelvin, put it right there. You divide it. And again, I'm using this equation. Divide that by the pressure, which is 120 atm. And you get 2.9623 liters of nitrogen gas, which can be rounded off to about 3 liters of nitrogen gas. Okay, thank you. If I explain this concept well, please patronize my page, and we can both help each other. Have a good night.